In response to my approximately $1,000 Linux gaming build, viewer JT7819 asks, if you have the parts, I'd like to see a Linux-based machine for average gamers, 60 series cards with 5000 series processors to show what the 60 to 180 FPS at 1080p to 1440p is for the rest of us. Well, JT, I do have the parts, so let's build something. Hey guys, I'm CJ. Welcome to Lifting Linux, where we open the door to open source. In this video, I'll be granting JT's request by building a capable Linux gaming system using components from a generation or two ago to keep the cost down to a manageable level. But to keep things interesting, I'm cramming it all into a tiny 5-liter case and powering it with Bazzite. Get ready for a boutique Bazzite box on a budget. Let's start with the components I selected for this build. Like most of my PC builds, it began with the case, and today we've got something a little different. In this box is the smallest non-HTPC ITX enclosure I've ever worked with. It just arrived from Japan and requires full assembly. I haven't even opened the box or seen the case yet, so unlike pretty much every build I've done, I'm not 100% sure if it's actually gonna work. We'll find that out together as I open and assemble the case on camera, but first, let's go to the rest of the parts. Most of these were already on hand, pulled from the shelves behind me. The only new items are the case and the power supply. So the exact components I'm using may or may not be available, and for my fellow US viewers, prices could vary significantly depending on when you're watching this. JT specifically asked for a 5000 series CPU, so I went with the Ryzen 5 5600X. For the GPU, I've got the Radeon RX 6600 8GB. Why that one? Well, A, it pairs nicely with a 6-core CPU, and B, it's the only AMD 6000 series card I own that can actually fit in this tiny case. Everything connects to an ASRock B450i Phantom Gaming Mini ITX motherboard paired with 16 gigabytes of Corsair Vengeance LPX DDR4 3200 memory and a 1 terabyte Team Group Gen 3 M2 SSD. Powering the system is a Silverstone FX600 power supply. It's a Flex ATX unit, which is the only PSU form factor compatible with this case, but it still comes with a full tangle of cable, so we'll see how that plays out during the build. Now, out of all of these components, the motherboard is probably the only one you won't find new. B450 boards, especially in the ITX form factor, have been end of life for a while now, so stock is getting scarce, but if you're not afraid of the used market, you can still find solid options. And if you are, there are some good prices on newer B550 or even B520 boards, depending on availability. Okay, let's unpack and assemble this case. Now, I did narrate the full build step by step, but for time's sake, I'll just highlight the key points here. First, the case arrives flat packed and well packaged. Nothing was damaged during its trip from Japan. All the outer panels are constructed from 1.5 to 4 millimeter machined media blasted and anodized aluminum with a 1.5 millimeter steel central spine. The assembly process essentially involves mounting all the PC components to that spine and then building the rest of the case around it. I started by installing the Ryzen 5 5600X on the B450 ITX motherboard. For cooling, I'm using a Thermalright AXP90 X36 low profile cooler. The M.2 SSD, which has a heatsink attached, installs on the backside of the board, followed by the RAM. After installing the standoffs onto the spine, I screwed the completed motherboard into place. Next, I secured the PCIe riser cable to the opposite side of the spine and then mounted the RX 6600 and secured it to the rear panel. And before the comments start rolling in, yes, I lost the I/O cover for this motherboard a long time ago, so well, bonus ventilation. Then came the Flex ATX power supply. I took some time to carefully manage and tie down the excess cables, and despite my initial concern, there was enough room. Tighten spots, sure, but enough to route everything cleanly. With the system assembled, it was time to attach the case panels. The bottom panel screws directly to the spine. I added a single Noctua NF A9x14 exhaust fan to the top panel, which also secures the upper vent panel. The trickiest part of the entire process was plugging in the power button. It's a tight fit in there. Using a set of machined steel blocks, the top and front panels screw together, and finally the side panel goes on. The 24-pin ATX power cable does press up against the left panel a bit, but it's flexible enough to flatten without issues. Ultimately, the build went together pretty smoothly, but that's because I planned carefully around the case limitations. CP cooler height is capped at 37 millimeters. There's room for two 92 by 15 millimeter top fans. There's no space for SATA SSDs or hard drives, and the GPU is limited to 2 slots, a maximum length of 261 millimeters and a max height of 135 millimeters. That said, you've still got plenty of options. The card I'm using is 195 millimeters long, which left me with plenty of space to tuck cables in front. If I went with a longer card like this 245 millimeter RTX 3060 Ti or even my 260 millimeter RX 7700 XT, there's still space above the card for cable management. Despite the constraints, I'm generally impressed with this case. It's extremely well designed, solidly built, and a great example of smart, efficient engineering. And at just over 16,000 yen or a bit more than $100 US, it's a phenomenal value for a boutique case from what I assume is a very small independent company. I'll leave a link to their Shopify site down below. It's not an affiliate link. I don't make any money from this. They don't even know who I am or that I'm making this video. I just found the case on my own and thought I'd share it with y'all. And stick around because later in the video, I'll tell you how one of you can get your hands on this exact case and, well, the entire system. With the system built, it's time to get everything set up. Step 1, make sure it posts. After connecting my display, keyboard, and mouse, plugging it in and powering it on, the system posted right away and launched into the UEFI. No surprises there. I had already bench tested the system beforehand, which is something I recommend for every build, but especially one as tight as this, where troubleshooting can be a real pain once it's all assembled. Inside the UEFI, I took a minute to make the usual adjustments, enabled the memory profile, disabled CSM, enabled rebar and PBO, and set the initial fan curves. That prior bench testing really paid off here, giving me a good baseline for those fan settings. With the UEFI configured, it was time to install Bazzite. Bazzite is a gaming-focused Linux distribution built on Fedora. It's what's called an immutable operating system, which means you can't mess up the core system by installing or removing the wrong thing. Perfect for gaming machines where stability matters. Bazzite is often seen as an alternative to Steam OS. In fact, it's designed to run really well on handheld gaming consoles and mini PCs, but it also works great on full desktops, offering a slick interface, built-in gaming tools like Steam and Lutris, and a ton of performance tweaks all ready to go right out of the box. First, I headed over to bazzite.gg to download the image. For hardware, I selected desktop and the modern AMD graphics card. I selected KDE as my desktop environment. Bazzite has 2 main interfaces, game mode and desktop mode. Game mode launches into a controller-friendly console-style UI, kind of like the Steam Deck. Desktop mode gives you the full desktop experience, browse the web, install software, do regular PC stuff. For this build, I went with desktop mode. Once the image was downloaded, I used Rufus to flash it onto a USB drive. Then I plugged that into our mini PC, powered it on, and launched the installer. As an immutable distro, the installation process is super simple. Select your language and keyboard layout, and you're basically at the summary screen. I did have one alert, no disk selected. That was an easy fix. I just picked my 1TB M.2 SSD as the install location. Back on the summary screen, you can choose to create a unique user, but I left it at the default Bazzite user for now, clicked begin installation and let it do its thing, and when finished, I hit reboot system. The system rebooted, ran a few updates, rebooted a couple more times, and finally landed me on the login screen. The default password for the Bazzite user is, you guessed it, Bazzite. Once logged in, you're greeted by, well, Steam launching and updating, and the Bazzite welcome app, which gives you one-click install options for additional software. For example, if you want to install EmuDeck, just toggle it on and click install. Bazzite takes care of the rest. You can always install these later using the software manager too. For now, I kept the default settings. First thing I really wanted to do was update the system. Again, you can update Bazzite using the software manager or from the terminal using the just update command. Bazzite uses a smart update tool called TopGrade, and once in a while it flags an update as a breaking change. That just means there's a major system level update like a new kernel or graphics stack that might change how things behave. It's usually fine to proceed, but I always recommend checking the release notes just in case something important requires attention after rebooting. That's why I chose to update immediately. Since I haven't customized the system yet, there's virtually no risk of breaking anything. So I went ahead and said yes. Because the image I installed was about a week old, there were quite a few updates to pull in. One difference with Bazzite compared to other distros, you'll need to reboot after almost every update. Once everything was up to date, it was time to prep for gaming, and this is where Bazzite really shines. Nearly everything you need for gaming, especially with Steam, is pre-installed. For example, Proton Up is already included, so you can easily download the latest GE Proton version. I grabbed GE Proton 9-27, and once logged into my Steam account, it was available in the compatibility settings. That's it. Once you install your games, you're ready to start gaming. Now, my personal gaming library is entirely on Steam at this point, but Bazzite also supports non-Steam games. It comes with Lutris pre-installed, so you can run exe installers through Wine or launch games from services like Battle.net or Epic Games. Personally, I prefer using Heroic Launcher for Epic, which isn't pre-installed, but you can grab it from the software center. Heroic also gives you access to GOG and Amazon game libraries. All right, let's see what kind of performance this boutique Bazzite box on a budget can actually deliver. I loaded up a handful of games from my library: Baldur's Gate 3, Cyberpunk 2077, Counter-Strike 2, DOTA 2, Marvel Rivals, the Monster Hunter Wilds benchmark, and because I'm a sucker for Japanese-style RPGs, I picked up Clair Obscur Expedition 33 and figured this was a good system to try it on. Now, I didn't run formal benchmarks, no spreadsheets, no bar graphs, just real gameplay, testing different settings and resolutions to see how each game feels on this system. Starting with Baldur's Gate 3 running the Vulkan API, I started at 1080p Ultra and jumped into my typical test scene. Everything looked solid, no weird texture issues, and frame times were nice and steady. Gameplay was smooth, and while you might spot a little micro stutter, that's just mouse-centered jitter. I finished the run with an average of 79 FPS, and the 1% loads were within 78% of that. So overall, really smooth. Then I bumped it up to 1440p high. Visually, it looked noticeably better in person anyway, and while the frame time dropped to 56 FPS, that's still great for this game. Frame pacing even improved a bit. 1% lows hit 82% of the average, so no complaints here. Counter-Strike 2 was up next. I ran it at 1080p, lowest settings, native resolution. I'm not a competitive FPS guy, but everything felt snappy. I averaged 232 FPS, but 1% lows were way down at about 40% of that. That sounds worse than it felt. This was just a bot match, which tends to hammer the CPU. Honestly, it felt smooth the whole time. There was a little input lag, but that's down to the janky mouse I'm using. Swap that out, and this setup would be totally fine for casual matches with friends. Not pro competition ready, but definitely playable. Cyberpunk 2077 at 1080p with FSR quality looked and ran really well. No texture glitches unlike what I've seen on some newer cards, and frame times were solid. Average FPS was good, and while 1% lows were just under that 70% sweet spot, a couple of tweaks brought them up to 75%. That smoothed things out and dropped latency without sacrificing visual quality. No surprises here, very playable. Our MOBA or RTS example, Dota 2, is always an easy one. I went with 1440p max settings, and as expected, the game ran just fine. I saw around 94 FPS on average and the typical random 1% dips that Dota tends to throw no matter what hardware you're using. Marvel Rivals is a different story. This game's rough around the edges, high CPU and RAM usage, plus some questionable optimization. I ran it at 1080p with FSR3 on quality and mostly medium settings. Frame times were messy, but gameplay didn't suffer too much. No major hitches, and I didn't feel like I was at a competitive disadvantage. Average FPS came in at 76, but 1% lows only hit about 40% of that. Still, for a game I'm not great at, it ran better than I expected. The Monster Hunter Wilds benchmark was the first real stress test. At 1080p high with FSR balanced and frame generation turned on, performance was technically playable, but there were definitely issues. Textures sometimes popped in late, like enemies fading into existence or walls fading out of existence, and there was some light stutter. The benchmark still rated it as playable, and I'd agree, but I definitely spent some time tweaking the settings to clean up those visual problems. And finally, Clear Obscure Expedition 33, the newest game I tested. I went with 1080p medium preset and used TSR at 75% scale. The prologue area is heavy on crowd, so more demanding than most of the rest of the game. But out of the box, the game looked good and ran better than I expected. I averaged 58 FPS with 1% lows within 78%, so super smooth. I did go back and test some other settings, and I confirmed while XeSS will improve performance, it just looks bad. A better balance of performance and image quality was using GameScope, and while I did test a lot of different settings, the best I found was going back to my original settings and making a few tweaks like turning off film grain, chromatic aberration, and dialing post-processing down. The final setup pushed frame delivery over 80% of the average, and for a game like this, that's what matters. A consistent frame time is way more important than just chasing high FPS, especially when you're timing dodges or parries later in the game. That said, I still couldn't fully clean up the shadows or shading issues. They're pretty rough and hard to ignore. So to answer JT's question, what can the rest of you expect, or at least the vast majority of gamers working with a budget well under $1,000? Well, you can expect a good experience, straight up. Most modern and even AAA titles are perfectly playable at 1080p using high to medium settings, especially if you take advantage of smart features like upscaling and, when available, frame generation. For older games, lighter titles, and esports stuff, well, you're wide open. Crank the frame rate at 1080p or bump up to 1440p for a sharper image, that's no problem. The takeaway here is simple. You don't need the latest bleeding edge hardware in a $2,000 or $3,000 system to enjoy today's games. No, I'm not playing Expedition 33 on ultra settings, max ray tracing at 4K with a high refresh rate, but I'm still fully immersed. The story, the soundtrack, the visuals, they all came through, and the gameplay is responsive enough to survive combat and actually enjoy the experience. And what made this all the more impressive was how flawless the Linux experience was. Bazzite handled every game I threw at it without issue, no crashes, no weird compatibility problems, no driver hunting, just install, update, play. It's smooth, it's stable, and it's packed with tools that make gaming on Linux not just possible, but enjoyable and accessible. And while Bazzite as an immutable distro might come with a bit of a learning curve, especially if you're used to a more traditional, fully open Linux setup, it's far more than just a gaming distro. Thanks to Flatpak support and containerized installs through DistroBox, you can turn it into a fully functional workstation, whether it's LibreOffice, Blender, Kdenlive, mail clients, or just about any open source productivity, creative, or development tool you need. Bazzite handles it all with ease. Now, before I wrap this up, there's one last piece I want to touch on: thermal performance. This is a super compact build, and that means using a very low profile cooler on the 5600X, but even in Expedition 33, which was the most demanding game I tested, CPU temps topped out at just 76 degrees Celsius, and the GPU peaked at 80 degrees. That's actually pretty impressive, especially considering that was with just a single top exhaust fan. Since then, I've swapped that out for 2 Thermalright fans, so thermal should be even better now. But now let's talk cost, because while I assume JT was looking for a system significantly cheaper than my Linux test rig, this one as built comes in at around $820. And honestly, when you compare that to most of the SFF builds you see on YouTube that have to include the latest Halo tier GPU, $800 is a solid price. Of course, if you wanted to go micro ATX in a $40 budget case with a cheaper B tier PSU, you could build this PC for around $600. So there's definitely room to scale this core system to fit your budget. But regardless of what all the parts are actually worth, one of you can actually buy this system, case, fans, GPU, all of it, for $599. Now, just to be clear, this channel makes literally no money right now. I mean, negative money actually. So to keep it going without resorting to ad reads or sponsored segments, I'm going to start occasionally selling the gear I feature here at a steep discount. I haven't nailed down the exact method yet. It might be an auction with a low reserve, but within a week of this video going live, you'll find a link in the description to the sale page. And hey, if you're not in a position to buy a gaming PC right now, I totally get it. You can still support the channel and help it grow for free. Just smash that like button, hit subscribe, and keep coming back for all the future content. I mean, it'd be wild if this channel hit 100K before my main channel, but honestly, with the support I've seen so far, I wouldn't rule it out. Thanks for watching, guys, and I'll see you in the next one.